So let's see if the mic's working. Okay, excellent. So first of all, I apologize for my voice. I'm slightly have a slight cold today, and don't worry if I break out in coughing fits, and if I should collapse, then please call someone to revive me. I hope everybody understands English, because this talk will be in English. Maybe just to head it off, who here has some form of responsibility for running your own software in production? Great, then this talk is for you to a certain extent, because this is very much focused on things that happen in production. To start with, it occurred to me on this Monday that there's actually a story that summarizes this talk very, very nicely. This Monday I was using the DB Navigator app. Who else uses the DB Navigator? Thought so, and it usually works flawlessly, but I was standing at a train station, and I was trying to book my tickets for a train that was also late, and the last step in the checkout failed. And it said, "You must have pressed that button twice." And I said, "No, I did not press that button twice." And I tried it again, and again said, "Well, there's something going on," and it took a long time. Then I tried it through the website, and that didn't work either. Then I tried logging out and logging in again, and it still didn't work. And that same evening, I booked a train ticket and tried Sofortüberweisung, and then I was actually allowed to pay, but I still didn't get a ticket. And at that point, I was hoping that there are people watching data coming in for production. Maybe there were some log messages somewhere that said, hey, there's a user in Bonn who's having trouble. Maybe there were some metrics and alerts that were showing high error rates. And I still don't know whether it had to do with my user ID or the way that I was paying, or maybe my phone version or something. But really, this talk is about connecting all these dots in a new world that is composed of lots of servers that have to interact, and finding out what's going on. And much of this is also inspired by experiences that I personally had over the past 1.5 years at Parfumerie Douglas, by the way. So let's head into that. My name, I'm John. I'm a freelance consultant. What I do predominantly is work on scalability and stability in general. So that means I get to clean up things that are somehow broken and make them less broken. And my background is in managing operations, managing software development teams, mainly in SaaS. And SaaS is a different game than e-commerce, because when something breaks, you've got customers yelling at you afterwards, but it's not as immediate in e-commerce, where every minute downtime actually costs you money. And that's why I like e-commerce, because it's so easy to say, let's invest into keeping the system from going down, or finding out whether it's about to go down, because you can really easily make the business case and say, hey, this is a good investment into better monitoring, or into better better stability measures. Stacktory, the name, is the website where I collect information around the overall goal of autonomous operations. Autonomous in that definition means we want to take the repetitive stuff, like the non-value adding activities, out of operating systems. And we're not there yet. Current tools don't give you that, and I think the overall software approaches are slowly going in that direction, but that's really where we're going. So, quick word about Parfumerie Douglas. Again, the story I want to tell is how we gradually improved observability and monitoring in that environment. Douglas is one of Europe's premier beauty retailers, operating over 2,000 physical shops, but also online shops for 21 European countries. And 14 of those are operated from the same team in Germany. And that is where this experience comes from. Maybe also less known, 25%, more than 25% of overall sales in Germany comes from the online channel. When you look at the top 100 German e-commerce shops, you realize that stability is not a given. This is the result of monitoring those top 100 shops for the past couple of weeks. And if you're one of those 80% that were never down in a single minute, then congratulations to you. You're doing things exactly like they should be running. Then there were 10% of the shops that were down in the early morning or the night. Maybe those guys were running monolithic stacks and doing deployments, or maybe they were doing load tests. We don't know. But then there are actually 10% of shops that were down during the daytime. And that shows that it's still not an automatic given process that your shop will stay up without investing some effort. There's a survey that I've been running for the couple of 4 months, or actually already, in SaaS and e-commerce around how people monitor their systems and what experiences they have. You can try scanning this QR code. That will take you to the link, I hope. And one of the main insights is that 50% of the respondents actually say, oh, we need to go faster and faster and faster. But at the same time, 30% say there are major problems with incidents and availability. And even though the monitoring and observability setups are getting better, obviously we're still not there, especially as the industry is going into more and more microservices and more things that need to be run and more things that need to be watched. So today I want to explain what observability actually means and how it's maybe different from monitoring. You could say, isn't it the same thing? And I will argue not exactly. Look into whose job it is, what we need to observe on the different layers from application to infrastructure. Head into a little bit about around containers and the whole cloud and ephemeral infrastructures that we're getting nowadays. And if we have some time left, go into how the ML and AIOps space might help in the future, even though I think it's not there yet. So what is the difference between monitoring and observability? In my view, it's really, monitoring is about the known unknowns. So maybe your system failed in the past, you set up a check, you set up a dashboard, you put in alerts, and then you're going to catch that same thing when it happens again. However, that may not help you catch a different thing that occurs, and it may not help you find those small ways in which your shop is not behaving like it should be. And that's really what observability means here, the ability of the whole system, comprised of many different services, to actually be debugged in an active fashion, to expose enough information to the outside so that it's very easy to see what's going on. And why is that so important? There's a fierce competition around happy customers. I can assure you on Monday I was a very unhappy customer. And it's no longer sufficient to say my shop is up 100% of the time. It's really about catching those small ways in which customers leave the shop in an unhappy way. And maybe while you were talking, you spotted the one unhappy guy here. Yes, that's him. So he had an unhappy experience, and we want to make sure that we can actually see all those cases in which customers have a less than ideal experience in the shop. One reason why this is getting such a hot topic is that in a monolithic stack, you usually have the luxury of saying, we're going to do a release, and then after the release, we're going to stabilize, and then we're going to work out all the bugs, and then we have a period of stability, and then the next release comes along, and then we get to stabilize again. But that's no longer the case. Even if you have the luxury of operating your own monolithic stack, then there are still outside services that are constantly changing. And there are deployments going on with your external providers, and maybe your infrastructure provider is doing things. So that basically means there is constantly something going on, and you no longer have the luxury of saying the system is in a stable state. Instead, you need to develop a capability to really go in on an everyday basis and find those reasons why things are not working like they should be. So in essence, what that means is any non-trivial system, especially systems comprised of many different microservices, are never 100% fully up. It's rather the question of how degraded are they? How many errors are you currently getting out? And I don't know if you don't know that at this time. And it was definitely an interesting experience at Douglas to find out how many small things are hidden in there. So again, to conclude, like the more theoretical part of the talk, definition of observability, in my view, is to say, let's not do SSH. Let's not deploy logging patches where you have a new version of the software with new log statements to find problems. Rather, we want our services to give enough outputs to the outside so that we can see what's going on by just looking at the outputs. So how can we do that? The classic 3 pillars of logging are, and I'm sure 3 pillars of monitoring are, I'm sure you're using those. You have logs. You start collecting the logs and aggregating the logs. Then you can do interesting analytics, say how many error logs do I have and where are they coming from, and maybe you can put alerts on that. But really that depends on those places in the code where you put statements. Then you've got metrics coming from infrastructure as well as applications. And then we've got, since a couple of years, we've got distributed traces, which really helped a lot. The good news is that basically, in terms of an observability setup, it's very likely that you have all of that at your disposal already. The question is just how to use it to detect these small things. So in a classic setup where the software developers would pass over a little bit of software to the operations guys, what the ops guys will do is they will put up a health check and say, I'm going to measure whether that process is running. I'm going to call a health check URL to see if it's still up. But the problem is that you'll not catch these things that are going to happen either between the health checks, or you might not cover all the functionality. And one experience we actually had at Douglas is that once we start focusing a lot on error rates on different levels, that we really get a whole new level of insight. It's no longer about is the system up or down. It's about how many users are getting errors on which page at the moment. And that's a totally different story than health checks, because I will argue that by looking at error rates, you're actually seeing the whole picture. You're looking at all the pages that your customers are currently calling. You are seeing real user behavior instead of a synthetic check. That also means that you can measure and report on a different and more meaningful thing. However, it also means if you have an SLA that says 99.9% uptime, it'll be have a different meaning than saying 99% success rate. And that's one thing that we learned at Douglas, to say, if we're used to telling our business stakeholders our shop was up 99.9%, and now we start saying 99.7% of our requests were successful, then it's going to raise a couple of eyebrows, but in the end, it's not tragic, because in the error rate, you always have certain things that are not the fault of your shop. You may have crawlers, you may have strange affiliate calls, query parameters that are incorrect. So there's a subtraction of there's a certain base level of errors that we'll need to put in there. In order to track that at Douglas, we were thinking intensely about how do we measure these kinds of request failures from the outside, because obviously we can't go in and say we're going to look at the own request logs that our web server is collecting, because then if our system is unreachable from the outside, we'll not catch those requests. What we did in the end was we collect the logs from the CDN, from the middle mile. So Akamai, our CDN, offers the possibility to ship you logs in real time. And we built a processing pipeline based on those logs that will gather up all the logs. Then it will group them in categories. So we will see all the search pages that our users are currently calling, all the checkout pages, all the category pages, etc. And it will calculate error rates based on that information. And what you see, and we're making this data available to the development teams too, and it gives you a real-time insight in how broken the system currently is. The trouble is, looking at the error rates, it really doesn't tell you much about why things are going wrong. It only says, well, you've got a 500 error rate, and that's tough luck. And one other unfortunate follow-up from that, from introducing the system, which is, by the way, open source, and you can check it out if you like. It's on GitHub, is that we actually saw a number of things that were going wrong all the time, which we previously hadn't really taken a look at. So as it turns out, there is a long tail of things that really shouldn't happen, but actually are happening. We spent I think, around 2 months chasing one small problem that would cause a certain backend system in certain unusual circumstances to take longer than 5 seconds to answer. And then our front end would say, we're not going to wait for you. It's a timeout, and we're going to return an error message to the customer. And as it turns out, that was actually a load balancer setting, obscure load balancer queuing setting that we could then change in order to bring the error rate down. And that we wouldn't even have seen that if we had just looked at averages and at average latencies, etc. These small things don't show up in the most metrics, and we need to develop this capability to drill down into the root causes. One thing that's really changed a lot in the way that we approach errors is introducing distributed tracing, also known as APM. I don't know how many of you use this. It used to be really expensive to be able to instrument your software so that you can see how traces flow from front end to back end to the database server. But it's proven a very valuable capability. And last year, we started rolling that out across 100% of our production environment. And what it actually shows you is it connects a symptom to a root cause, in my view. With the distributed architectures that we're building, there is an increasing distance between where the error actually gets sent to the user and where you might measure it from the outside and what's actually causing it. We had one obscure case where an external service would return suddenly an XML file that was referencing a DTD that was hosted somewhere in the US, and it took 15 seconds to retrieve. And every time a user hit our page, that thread would wait 15 seconds for the DTD, and then our thread pool would fill up, and we would not be able to accept new requests. And that's really hard to find if you don't have some possibility to find out how these things are connected through the stack. So if you're not using distributed tracing, highly recommended, and there are good open source tools that do that now too. Another insight that we gained over 1.5 years of looking at alerts and monitoring metrics is that the type of alert that's here at the bottom really isn't that useful or actionable. And unfortunately, we still have a couple of those because this is typically what you build first. You say, I have got these infrastructure metrics, and I'm going to define thresholds, and they're going to alert me when something is going wrong. But as it turns out, that really doesn't tell you much about what the user impact is. It just says, CPU is too high. Maybe that machine is just doing its job. However, if we have alerts that are coming from the application side and from the user side, that's a lot more actionable. However, they don't tell you what's going on underneath. So if you have to choose, our experience so far is to say, if we have to choose, then better alert on the top of the stack and use the infrastructure alerts more as a means of telling you what's going on, something that it can be used reactively in troubleshooting. And I think that's an overall development in the industry, that the alerting is moving up the stack to the application layer and to the user layer. Maybe you're putting in JavaScript tracking to see what the users are seeing. You're putting in Prometheus endpoints into your apps and polling them. And you're paying less attention to the infrastructure side in most cases. And that is actually a good thing, because when we're moving to cloud, we're moving to a cloud infrastructure, and the whole infrastructure management is becoming basically someone else's problem. And even in a cloud environment, you add Kubernetes on top, and suddenly you've got another layer of abstraction and virtualization on top. And then your applications start moving from host to host, and then it becomes very hard to connect something that you saw on the app side with a possible cause on the infrastructure side. If AWS sends you an email about degraded hosts, you'll sometimes have trouble finding out which applications does this actually impact. And that's why moving a bit beyond what we currently have, I believe there's a new set of tools that we basically need to build that help you connect all of this. We have a certain measurement of the business processes already. We know what a user journey is like, from homepage to search to categories to cart to checkout, etc. And we're reasonably well able to connect the traces, the actual URL calls, to those processes to find out what's going on. What we can't do very well yet is to find out how these things are connected on the infrastructure side. And I think that's something that is fairly easily discoverable. If you're running on cloud, then you can actually use the APIs to say, this load balancer, which nodes are inside this load balancer distribution? What software is running on those nodes? What disk volumes are underneath, etc. And this is, I think, instrumental to connect all the dots, connect all the different monitoring systems going forward. Actually, our APM tool does a little bit of this, and it aims to show you some incidents and generate alerts. However, we have found that it really doesn't know enough about how things are actually connected from the user perspective. So what it currently does is it shows you your disk space is about to fill up, or there's a high error rate on some kind of service, but it's somehow missing the connection to what does it actually mean for your user. And this is where AIOps tools specifically hopefully will help us manage things in a better way in the future. One thing I also wished our observability setup could do, and what we're doing manually right now, is actually forming some connections between things that we see. Specifically in the Black Friday experience in 2017, where we had a couple of issues. I wish we would have known beforehand that there is a very simple relationship here in the backend system, which is once the CPU usage on the backend is too high, then the threads start hanging on to their DB connections longer, and then what our users see is higher latency. And if that gets too high, then eventually the system falls apart. And there is no reason, in my view, why an automated system should not be able to see that and form an opinion. It's just that they don't. You could look at all these metrics. You have them in your time series database. Maybe you have 5,000 time series in there. And if you have the topology and you know how things are connected, you could have a system that goes in and says, hey, I see a clear correlation there. Maybe this thing over here is a root cause for what's happening there on the top. Again, this is maybe not where the tool industry is right now, but I don't see any reason why this is not something that we can immediately do. So we're nearly at the end of the allotted time. Just want to go a little bit into the way analytics, I hope, will help us soon, and the DevOps tool chain. So I think from the observability perspective, where we currently are is somewhere in the descriptive and diagnostic layer. So we hopefully can look into the systems and see what happened, and maybe we can see the root cause already, even though for the root cause analysis, we really need systems that understand more about how your things are connected. And that's where APM tools again come in. Where I don't see an immediate solution yet, but I would love to have, specifically in cases of high load or during a load test, is to say, hey, can't my system simulate what's going to happen? If you know what's going to happen if I have 2,000 orders per hour, why can't it then say what happens when I've got 20,000 orders on the system or 200,000? Statistics would help you do that. And in the end, if we have robots watching our metrics and forming opinions on how they're related, why shouldn't they be able to go into the system and resolve any issues that we're seeing? And that's actually something that is already being built in auto-scaling groups, for example. So AWS in their auto-scaling has more intelligent forecasting now. And I think things are generally getting better, but I don't see any system yet that can tie all that together. So in the end, what's needed is, going forward, to say, where is the feedback channel from production to dev and ops? I think the industry has gotten very good in building tools that help you deploy software rapidly into production. But what we need to build next, and what is being built as we speak, is basically this feedback that goes back to say, can't we get some automation in how we generate insights from what's happening in production and get that back into the development lifecycle so that we can address all these issues and have basically a tighter interaction between the people who are building the systems and how they are performing in production. So I'll finish on time to give a little bit of time for Q&A. I know this was a very broad view on the observability landscape, but if we want to focus on some takeaways, our experience so far has been no system beyond a certain level of complexity is ever 100% up. And we need to build a capability to find all these very small ways in which the system is degraded and fix them, because they will pile up if you don't. In monitoring, focus on the application layer. That's where it matters most for the users. With some exceptions, if you have crucial bits of infrastructure that simply cannot fail, obviously you need to alert on those too. There's no sense in looking at the application if your network connection is gone. But really, it's about the application layer. Distributed tracing in production, our experience is that it makes a world of difference. And we stopped worrying about the overhead that it has in performance, in terms of performance. Everything worked well in general, and it's not cost prohibitive anymore either. There are good open source alternatives. I can highly recommend it. And collecting data from multiple sources is something that needs to be built by hand at the moment, I'm afraid. But that's definitely something that we want to go into. And in general, your organization, if you take this seriously, needs to develop capabilities to deal with this influx of connected data from monitoring data from various systems. And we're not quite there yet, but I hope we can get there soon. And that's maybe a good end for this talk. And with that, I would hand over to Q&A.
How long would you say it takes at a minimum to get started with distributed tracing if you haven't anything in this direction?
It depends on how up-to-date your technology stack is, in my view. The biggest issues we had were incompatibilities between this version of Java and this version of the distributed tracing agent, where the agent, or what the agent was doing, actually increased the probability that that Java version would run into a GC bug. And that took a while to straighten out, and that is one of the real risks. So I think there's a risk on the way to APM that you may run into production issues, and you may say, it's not worth the risk. But if you push through this stage, I definitely find it worthwhile. There is a little bit of customization effort, usually. I've been through this with App Dynamics, where it was quite a bit of work, and I've been through it with Instana, where it wasn't quite as much work, and I haven't been through it with open source tools. But my assumption is that with things like Jaeger or Zipkin, you probably have to invest a bit more upfront to actually make sense of your traces, to tell the software how your stack actually looks and translate the information that it gets into something that you can actually digest. Does that answer the question?
Not completely. I've still got no numbers.
Yeah. So our journey here was, I believe, between 6 months between starting and full rollout in production. However, you need to subtract this the stage where the initial rollout ran into issues, and then other things became more important, and then you realized, okay, it is actually worth the investment, and I need to put in the work and get started.
Yeah, but probably this is always the reality, so I think this is a true number.
Yeah.
Thank you.
Could you mention the tools that you're using for distributed tracing? Because it used to be really prohibitively expensive with things like Dynatrace and New Relic and stuff. And you mentioned something about open source. Can you recommend something in that area?
Yeah. In my view, there is sort of you mentioned the big traditional vendors, and I've been through proposals with, again, AppDynamics, Dynatrace, and New Relic at that time, where you went close to 7 figures for a reasonably sized infrastructure, and then you rapidly decide that it's probably not worth it, and then you start thinking about, oh, will I only instrument the staging environment, and then you decide, well, what use is it really? Because I'm not seeing real production data. So really, this should be in production. So this is still the top of the price range. Datadog, especially too. I like the tool, but it's really, really expensive. Mid-range, I see a couple of new vendors coming in, like Instana, which we're using, but also, for example, Lightstep, or there are a couple of others in those space. Raygun is building APM. And on the open source tool side, I think that there's going to be a lot of movement towards Jaeger, because it's embedded into lots of the Kubernetes stack. Many tool sets have that in there, and as long as everything is based on open tracing, then there's probably not a lot of technology risk in sticking to one vendor, because it gives you some ability to at least move to another vendor without having to change the way your software is instrumented. Answer your question? Okay. Okay.
What would be your recommendation for a sampling rate when using distributed tracing that would make sense? And is there any impact of that sampling rate on the overall expense?
The financial expense or the performance expense?
Financial expense.
It depends. I mean, there are vendors that will charge you by trace, which kind of makes sense. I mean, traditionally, APM has been traced per node per host, and I think it doesn't make a whole lot of sense in a cloud environment. As soon as you're auto-scaling, it becomes really hard to calculate. Paying by trace actually makes sense, because then, as you mentioned, you could adjust your sample rate to say, I'm only going to look at every 1,000th trace, and that's enough for me. Our ambition here, and also that something that came out of the licensing model, was to say, actually, we want to capture 100% of the traces. Like, if there's one unhappy user somewhere who's standing there and is in desperate need of skincare products, and I can't deliver them, I want to see who that is and why that user is having a bad experience. So if there's a choice, I would always go for 100%. And if the impact the question was the performance impact, what the Instana agent does is beyond a certain if traces come in too quickly, it starts dropping them. So what it does in the end is it automatically throws away traces and then does sort of like dynamic sampling, but that has proven to be less than useful in many cases, because then you got different moving parts that are dropping different traces, and then you get hardly a trace that really goes through.
As far as I know, Douglas is an on-premise solution at the moment. They're scaling into a cloud solution. Do you have any experiences using it in Google Cloud or something like that? Because we use Dynatrace in a Google environment, and actually we stopped it like 2 weeks after we started because it was too expensive, and we had no real solution how to select which traces we should trace and which not. And the customer decided that the tracing cost is too expensive compared to the revenue that it's generated with our tool.
So what is your exact question?
Do you have experience with cloud solutions, and do you have solutions how to select the traces in cloud solutions? So would you recommend anything on that part? So because Dynatrace just said trace anything, okay, I see that. Because
I was wondering that it seemed like a twofold question where you said, first of all, it was too expensive, and second, the value was not there because maybe the semantics and maybe like the topology of how things should look from your perspective wasn't there. So
yeah, it's both. So the major question is, if I'm running it on premise, I can select exactly what I want to see in Dynatrace. If I'm running it in the Google Cloud, it's not that easy. So our DevOps said. Do you have any experiences using it in a cloud environment? And if so, do you have any experiences how to use it in a more cheap way? So by selecting traces or selecting only one node, or how would you do that?
Yeah, unfortunately, I haven't been in the fortunate or unfortunate situation of running Dynatrace in the cloud. The state a couple of years ago, again, was that the licensing model makes it really unattractive because they were selling agents for a perpetual fee or on an annual subscription basis, which again in an auto-scaling scenario makes no sense at all. I believe that they have a model now where they will charge you per instance hour, which is a lot more cloud ready. Other than that, I'm not sure how they really perform on a cloud scenario. What I do know, or think I know, is that Dynatrace is also going into the APIs and will, for example, get a view of how things are wired up on the Google Cloud as well as AWS. But I can't offer you any specific advice, unfortunately.
Okay, sad. Thanks.
Okay. Thank you very much.